Hello guys, it's welcome back, right? Welcome back to Python on Pydroid3 mobile app, Pydroid. Okay, so what we are going to do now, we are just going to talk about numbers, floats, and how to use them in programming. That's an M there, numbers, floats, yeah. So we're gonna work with the interpreter throughout this course, or whatever this is, throughout this short note. We're going to talk about numbers. Now, numbers are used in programming languages. Say perhaps you want to keep your score in a game, you want to read through some data, you want to get information from the web. You're going to make use of numbers, right? You're going to make use of numbers. So let's see how to use the numbers. So for example, we have integers, which are whole numbers, and we can just say 5. We can say 5 plus 4. We can do regular addition. We can say 6, and we can say 6 minus 2. Okay, we could also, if we did negative number, we said 5 minus 7 gives us what? Minus 2. We could also multiply using the asterisk here. Please note that asterisk is what we use for multiplication. 7 times 4 gives us 28. And we could also divide. The backward slash is a division. So 7 divided, let's try this instead. 9 divided by 3. We want to get a whole number, right? But notice here it gives us a float. That's the first point to note. Floating point numbers, or just in the regular world they're just called decimal. In computers they call floating point numbers because, well, it's just to make it cooler, and to be honest. But they are about numbers that are the fact that the points can appear in any point in a program. It could appear here. It could appear before the main number, it could appear in the middle, it could appear at the second place or the third place, yada yada, all the way. That's why it can float to any point, right? Now, because of that, we use the floating point numbers for precision. Right, cool. Now let's talk about the other operations we can do. We can also use a double asterisk to denote exponents. And we know exponents, some people might know it as raising to power, or the square or cube, blah blah blah. So let's do a 4 square, that's 16, and let's do a 4 cube, hopefully that's 64. Okay, and we could go on like that. We could also do 10, and we can see what happens when I raise it to the power of 6, and we get a huge number. Great. Now that we have that, another thing we could do is we could go back and talk about floats now. So let's say 0.7 plus 0.8 or 0.9. It gives us this number here. One thing to note about floats is that it tries to be as precise as possible. That is why, and it's the same for all programming languages. It's not unique to Python. It just happens this way, which is why we have this going on here, right? It tries to be precise, so it gets to the nearest or to the most precise point that it can go to, right? Cool. Then we could also check out, but you don't have to worry about it. Your main answer is still here, 1.6. So let's use an easy example. Let's say 0.4 plus 0.3. This answer is going to be 0.7. Yeah, it's going to try and give you, just raise it up to the nearest number, right? We'll talk about that later on. Now that's what floats is, that's the magic of floats. And also something to note about floats is that if you try to do you call a number like this 3.0, right? And you say multiplied by 7, it's going to give you a floating point number. Why? Because when you think about it, if I was to say 1.0 and I say multiplied by 7, it's just going to give me, it's just going to automatically transform that number into being a floating point number. Anything you do with an integer, and it doesn't have to be multiplication alone. If you try to do, I don't know, like you try to do an addition with a floating number, it's going to give you that. It's going to give you a floating number as well. Okay, it's going to give you a floating number. Cool. Now let's declare a variable. Let's talk about, sorry about that, my keyboard acting up. Let's talk about variables. So let's say we could also do something really cool. We could try and make a big number. Let's call a number called mega. Let's say mega is equal to a huge number, like, I don't know, I want to space it out. We can use an underscore and say 23 Let's go like this and just go. I don't even know what this number is. Is it 23 million? So Python is not going to see this as an error. I'm just going to have that. And when I print out mega and I say, hey, interpreter, return mega to me. That's not mega, that's a different variable. Hey, stop with the caps. Stop with the cap. Okay, so if I say print back mega to me, what happens is that, yeah, mega is printed out without the underscore. So it's a cool way. At least I know that mega is 23 million, but Python doesn't really care about the underscores. I just use it so that I can visually make sense of the program. Another cool thing I could do is Python doesn't have, in programming there's something called constants, and other languages have it, and a constant is a variable that doesn't change throughout the life cycle of a program. And now we could have constant. Most times we say constant is in all caps. So the way we can try to cheat in Python by using a constant in all caps is that we can say, I'm just going to say what can I have as a constant? Let's say a max date or max data. Let's just say that the max data is going to be equal to, let's say it's going to be equal to 544. Although this value can change, but once I type in this max data in all caps, I know that, hey, I don't want this value to change. This is why I put it this way. It's just a helpful way to help me remember. A cool thing we could also do is we could also assign variables straight up. Let's say we have values for far, near, and let's say short. And we have three values here, right? We have this one far, sorry. We have far, we have near, and we have short, right? Cool. A cool thing we can say is that we're going to assign values here. And notice that I use a comma to separate them. A comma here, a comma here. So I'm going to use a comma, and I'm going to say far. Why am I using far? Well, maybe let's just say far is going to be 34, right? And near is going to be a closer number, right? Like maybe 15. And short, which is similar to near, is going to be a different value, and I'm going to say 45.0. Cool. And when I run the code now, we can actually call short, and it's going to give me what the value of short is. Short is what? That's 45.0. And if I said what is far, it's going to give me 34. And if I said what is near, for example, it's going to give me this. Okay, cool.